This is RETScreen 4. There's some other variations of RETScreen that comes with it, but we're using RETScreen 4. Now, RETScreen is just what I call a very elaborate and sophisticated Excel sheet. If you look at this, let me do a pointer here. Hopefully you can see this. If you look at this as C product database, there is a host of templates that can be dropped in to multiple pages here. It drops in with representative numbers in, which might represent that particular renewable energy or energy efficiency or whatever it might be, typical numbers to represent that. But we can change all of those. So what we want to do here is we want to design solar PV system for a particular set of electricity data. We want to design a standalone system, and we want to then design a grid connected system, which we'll call net zero. In other words, it will produce as much annually as the electricity is being used. We need some data to start with, some electric data. So we'll just use the data that we used on our homework last week, and I have recorded those, so we'll use those. Okay, first thing let's do, let's click on this product database, and you should see that little square come around. Now, warning. If you click on one of those cells twice, it will tell you it's locked. So what you need to do, click off of it and then click back on. So if you happen to click on it twice and it says it's locked, don't believe it. It's not locked. Just click off of it and click back on. Okay, so what we want to do, we want to find one of these that is for one of these formats, which is for a standalone PV system. I have to look a little bit to find them. I don't remember where they all are. Oh, here we go. Power, photovoltaic system, 0.4 kW off grid. So we're going to highlight that. Now it says 0.4 kW. That just drops in that name. That's not what we have to do. We'll do what we want to do. But that just drops in some representative numbers so that it can drop in this format. Click the little green box. It says, do you want to save the change? Well, there's nothing to save, so I say no. Sometimes it takes a while for it to drop in, but there it does. Now, this program, RETScreen, was put together in Canada. That's why this is on there, but we're just going to say Dayton, Ohio. We'll come back and change this. And it's for EGV, was it 1401? Prepared by we're doing power. There's little, you don't see it right away, but there's a little drop down box, power, heating, cooling, combined heat and power, and the list goes on. So we're doing power, photovoltaic, another drop down box that we can pick a multitude of things, but that was dropped in when we dropped in that format. Off grid, oops, off-grid. Let me show you something here. Central grid, that means like you're just supplying electricity to the grid, just to the grid, not any internal loads. Then you have central grid and internal loads. That would be like if you had this at your home, where you're connected to the central grid, but you're also using this electricity. Isolated grid, that would be in some areas of the world, they have an isolated grid that's just for a community, and so on and so forth. Well, we are off-grid. Method 1, method 2. We normally use method 1. I'm going to click on method 2. Look down here at the bottom on this toolbar, energy model, cost analysis, emission analysis, financial analysis, risk analysis, tools. It does a whole lot more than we really want to get into at this stage. Higher heating value, this is high heating value or low heating value. I may or may not get into that a little later. I need to select my climate zone. So I'm going to pick the United States. And I will pick Ohio. And there's multiple selections for Dayton. There's Dayton. Let's just pick straight Dayton. And this is all of the data that's associated with Dayton. And I click this little box down here, and that drops that in. Now, if we want to show what this data is, I click on that, and now that's shown down here at the bottom. You probably can't see it all. I'm going to go ahead, yeah. So now I think we have everything filled in here, except that we don't have the size of the system. That has nothing to do with the calculations. That's just like a name. So now let's click on Energy Model. And it's off-grid, grid electricity, fuel rate dollars per kilowatt hour. That is probably about 14 cents. Capacity of our system, well, that's a guess. For right now, I'm just going to say 10. I really don't know. Operation and maintenance costs. And it's the fuel rate, but none of that means anything right now because we haven't filled any numbers in. There's method 1. I'm going to click on method 2 just so you can see that. Method 2, we would have to list all of our equipment in this house individually. And if you have utility data, that is a better way to do it. So I'm going to go back to method 1. Now, electricity, daily DC, there is no DC. I'll put a 0 there and a 0 there. Now you see it has a base case, has a proposed case. We can use this that if we are have some base case and we say, well, what if we did this? That would be our proposed case. So, but we are going to just keep them both the same. Now, daily AC electricity. Well, we have a different amount every month. I have those recorded here, so we'll be using those. But I'm going to click on this percentage of month use. Up here comes this table. So now what I put in here, I put in the month that I used the most. And if I look back at our data that we had on our homework last week, there's 60 kilowatt hours per day. That was our maximum. So I'm going to put in 60. I'm going to put it on both sides. Now here, this is a percent. So in January, we used 56. So what we do, since this is Excel, we'll do our equal sign. And then we'll put 56 divided by 60. And that gives us a percentage. Drops down to the next box. February, we used 46, so equal 46 divided by 60. Then for March, we used 44 divided by 60. April, 44. May, 43. June, 55. July, 51. August, 60. September, 52. October, 45. November, 41. And December, 34. So now I want to just drag these over. So all my proposed cases, oh, that didn't work. Okay, have all of them copied over. So now DC, nothing. AC, 17.4 million watt hours. Peak load, I'm going to put 200% there. Don't worry about that. Just put a number in. Now then, inverter capacity, I'm going to put in 20. Don't worry about that. Now, how many days of autonomy did we do last week? We did what? I'll pull it up. And 3 days of autonomy, 48 volt system, 75% depth of discharge, days of autonomy, three, voltage, we're going to 48, efficiency of the battery, 48, maximum depth of discharge, we said 0.75, oops, So it's 75. Charge controller, ambient. Well, batteries act differently if they're out in the cold or if they're in the warm. So we're going to say constant temperature, and we're going to do this in Fahrenheit. And I'll say 70 degrees. Let's see, it wants to know the efficiency up here of our inverter. I'll say 90%. Miscellaneous losses, 3. Solar tracking, well, it's fixed. Slope, we're in Dayton, Ohio, so let's set it at 32. Now, monocrystalline, polycrystalline, then there's thin film. Let's pick polycrystalline. Go over here to the side. I'm going to click on my database. And I get to pick. And here, I'm going to pick 165 watts. Start off with, I'm going to pick 40, just a guess. Clamped, well, remember we talked about maximum power point tracking. We want maximum power point tracking. Capacity factor, that is how much it produces relative to its design. Let's see, electricity delivered to the load, 42.3%. Well, we're going to have to go back to our product design, product database, sorry. Click on that again, and I'm going to pick 90. Okay. Now I just have 90%. I'm going to go back to my database again and pick 100. Okay, now we're at 96.8% of what we need. We need to go back up here on the batteries. This little number over here tells us the amperes that we need, so I'm going to put 60. This tells us what we need. So we still haven't produced enough yet, so we really have to go back to the product database. I'm going to take it up to 110. I finally am producing enough with 110 modules. Size of our system is 18, a little over 18 kilowatt system. So we have designed an off-grid system. Needs 110 units. Size of the system is 18.15 kW. Tells us how many batteries that we need. It says here we need 58 amp hours. Here we put in 60, just so we're a little larger. Now let's go back and let's change to central grid and an internal load. That's grid connected. Load and network. Well, we have to kind of start over. Now we want the kW, and we are given that we're using so many kilowatt hours per day. So really what we have to do is take our kilowatt hours per day and divide it by 24 hours per day, and that'll give us a kW. So on January, we had 56 kilowatt hours, so equal to 56 divided by 24. Then in February, we had 46, so it's equal to 46 divided by 24. March, 44. May is 44. Now you notice these are just integers that we see popping up there. It really saves the decimal places back in its memory. It just lists this in integers. So now we are May, which is 43. June, which is 55. 51. 60. 52. 45. 41. And 34. Peak, I'm going to put 200 again. Electric rate, 0.014. There we go. November was 41. December was 34. Okay, so now we go to our energy model. And here it says guess the capacity factor. Well, I sure don't want to do that, so I'm going to pick method 2. Tracking mode is fixed. Slope 32. Azimuth. That means direction with respect to south. I'm going to go up here, click on the question. Zeros due south. You have to be careful of that. So let's go ahead, let's pick our polysilicon again. And let's go ahead and pick, let's pick the same one. Let's pick about 40. Remember it took about 110 last time? Let's pick 40, just a guess. I don't know if you could see that. There we pick the same module, 165 watt module. We're picking 40 of them this time. Miscellaneous losses, 5%. Inverter efficiency 90%, capacity 20 kW, miscellaneous losses, I'm just going to put 1 since I put 5 up there. Electric rate per million watt hours. So for a kilowatt hour, it's 1,000. 140. Electricity delivered to the load 8.6. million watt hours, and we need, I'm going to go back here to the load, we need 18 million watt hours, so we need about double that. So let's go back, I've gone back to my product database, pull it over here where you can see it. I'm going to pick 90. Okay, now you see that delivered to the load, 17 megawatts, exported to the grid, a little over 2, so that's 19, a little over 19. So we're producing a little bit more than what we're using because we're using about 18 million watt hours. We're producing those two together, a little over 19, so that's close. So we had 110 modules on our standalone, and we have 90 modules on our grid connected. Okay, so we have designed, using RETScreen, we designed a standalone system and a grid connected system.